Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Stellar Nebula Cloud Structure. Now, in article 169 entitled Planetary Formation, Comets to Planets, I wrote about the solar capacitor, which is a series of rings or nebula clouds centered on a star, which are produced from the star's production of solar wind. The concept came from James McCanney, who in his book Planet X, Comets and Earth Changes describes the structure of these nebula clouds in terms of capacitor plates and calls them the solar capacitor. According to him, these nebula clouds are made out of positive ions, which the sun ejects as solar wind, with the heaviest remaining in the cloud closest to the sun, and the lightest moving to the furthermost cloud from the sun. He also states that the negative plate is the sun's mainly electron outer layer, or corona. He deduced the structure from observing the behavior of comets and how they seem to absorb the material found in their tail from their environment. So here is the structure that James McCanney proposed for the solar capacitor. We have the sun, we have the negative plate inside the sun's corona, and then all these plates are positive, and they are full of ions. Now, the nebula clouds and ions are, of course, atoms with missing electrons. That's what makes them positive. Electrons are negative. The nucleus is positive. So, with missing electrons, an atom becomes positively charged. And so, these would form the capacitor plates. And now, what we would then have is a comet. As it comes in, it absorbs ions from the cloud behind it, and it absorbs electrons from the sun's corona. So this would be a current of electrons, this would be a current of ions. They meet here at the coma and in the tail, and they react, and they would form atoms and molecules such as water, sulfur dioxide. That's what we find in the comet's tails. Now, all stars which still retain enough energy generation power in their cores to produce a solar wind will have either a nebula cloud structure or ring structure around them and centered on the star. Since Jupiter has nebula clouds and Saturn has a ring structure, they should therefore both be viewed as stars, not planets. And here I have drawn Jupiter's nebula ion cloud within the sun's nebula ion cloud structure. And this James McCanney also deduced this from observing what happened with comet Schumacher-Levy 9, which, when it passed into the region of Jupiter's capacitor, it started drawing in through its tail sulfur and oxygen instead of hydrogen and oxygen, and thus the tail went from containing water to containing sulfur dioxide. And this showed that Jupiter's nebula clouds contain sulfur and oxygen rather than hydrogen and oxygen contained in the sun's nebula clouds at Jupiter's distance from the sun. Now, young and very energetic stars are likely to have the largest nebula cloud structure, which may also emit light, which is the reason why so many stars have what is called planetary nebula. These planetary nebula are usually attributed to being the result of a star having gone through a supernova at the end of its lifetime, so that the star at the center of the nebula is viewed as a dead star. Actually, what we have is the exact opposite. Only a young, energetic star is able to have a strong stellar wind, which will then give rise to a large planetary nebula. Old stars, as we know from observing the stellar cores in the sun's corona, are not able to emit light or have a solar wind because they are no longer able to generate energy in their core. And you may look at article 184 entitled Stellar Core Evolution for more details on that. Thus, a supernova cannot signify the end of a star's life, and is therefore most likely what occurs when a new star is born, possibly by fissioning from another larger star. And here we see some planetary nebula. This is the Ring Nebula, also referred to as M57. As you can see, there's a star there at the center. And there's a star at the center of this one. This is called the Helix Planetary Nebula, or NGC 7293. So these planetary nebulae are always characterized by a central star surrounded by a cloud of gases, which usually form a ring or a toroidal pattern. The gases must be ionized and are thus the star's nebula clouds produced by the star's stellar wind, and are thus created as a result of the energy the star is able to generate in its core through radioactive decay. Only a young star will have the energy to produce such a beautiful nebula cloud structure. And you may look at Article 254 entitled Planetary Nebula and Death of a Star for more details. Now this is what the zodiacal ring around of a star looks like. This would be the first ring structure around the star. So it would contain the heaviest ions that are ejected by the star's solar wind, such as iron and nickel. And here's an illustration of how the toroidal rings or nebula clouds increase in height with distance from the sun, and are thus similar to the Earth's Van Allen belts. As you can see, this is the first one. This would be the zodiacal ring, and then you have several others as we move away from the star, in this case the sun. And then if you're outside the solar system on the ecliptic plane, this would be what the sun's nebula cloud structure would look like to you. You would only see the outside ring, which would have the greatest height. Now, although the structure proposed by James McKinney works very well to explain the phenomena surrounding comets, such as the production of a comet's tail in coma, the fact that the Earth's Van Allen belts, which are equivalent to the sun's nebula clouds, but for a planet, are made of alternating positive and negative rings, with the negative ring on the outside, has made me realize that this is also most likely the structure of the sun's nebula clouds, i.e., there must be negative electron clouds interspersed by the ion clouds, and that the last nebula cloud at the boundary of the solar system and interstellar space must be a negative electron cloud. And here we see the Earth's Van Allen belts. The red one, the inner one, is filled with protons, and the blue one, the outer one, is filled with electrons. Every object in the universe, isolated object, except for the stellar cores that have died, have an outer negative layer. This is why atoms have electrons on the outside, and this structure is to do with the gravitational interaction. And for more details, you may look at the book Planet X Reveal Gravity and Light. I have written many articles on this, but it's just too difficult to explain it, how it all came about each time I do one of these articles. So this is how I have done the solar capacitor now with nebula ion clouds. These are the orange clouds, and with electron clouds. I'm not sure exactly where they would be. Some may even be inside the ion clouds, but we should have one last cloud. The last cloud would be an electron cloud, a negative cloud, because that is the structure of all objects in the universe, and is the structure that we have on the microscopic level, i.e. atoms. Now, the electron clouds are analogous to the energy levels of an atom, and the most energetic electrons will be in the outermost layer. These electrons will have more gravitational energy in them than electrons in the inner layers. The electrons are kept in the appropriate energy level, which is at an associated distance from the Sun, by the balance between gravitational force generated by the Sun in its core and the electrostatic interaction between the particles in the core and the electrons. Thus, the whole heliosphere, which is believed to go out to 100 AU from the Sun, is the Sun's atmosphere, and all the planets move within it. The planet's outer layer of electrons will have the gravitational energy appropriate for the distance at which the planets orbit from the Sun. Now, the nebular ion clouds are produced by the Sun's gravitational field, but indirectly. The gravitational interaction causes protons and electrons to repel, and the higher the energy in the particles, the stronger will be the repulsion, which is why electrons with more gravitational energy end up further from the Sun or further out from the nucleus of an atom. But the nebular ion clouds are ejected from the Sun as a result of the electric field generated in the Sun's outer layers, or the inner corona of the Sun. The field results from electrons being repelled by the dense positively charged core. The electric potential rises steeply in this region, i.e. the corona, and results in electric discharges which lead to the emission of high energy photons, which then split into particles. Fusion occurs and several heavier nuclei form all the way up to iron. These may absorb electrons, but they are then ejected away from the Sun's corona depending on where they form. These nuclei or ions, if they have acquired electrons, may be pulled into the Sun's interior or ejected into space outside of the corona. If the matter creation event occurs closer to the top of the corona, they are repelled by this mainly electron layer out into space and become the Sun's solar wind, which then feeds the nebular ion clouds of the solar capacitor. And this is illustrated by this diagram. As you can see, we have the interior of the Sun, which is solid. It will have a core, which is the densest part. And then we have a transition layer, which is the chromosphere, which is, I believe, seems to be mainly a liquid layer. The corona is gaseous. And what we have is discharges which occur either in the chromosphere or in the corona itself. And this is because there's a very high electric field that occurs in somewhere here in the Sun's outer layers. And these then give rise to high energy gamma rays which split into particles. And then these particles undergo fusion, and thus heavier nuclei form, and then they are ejected away from this layer because this is mainly electrons, and the gravitational interaction causes the protons, or mainly positive ions that form, to be repelled by this layer. So they either move back downwards towards the bottom of the corona or the solid part of the Sun, as you can see here, or they move upwards. That depends where they form. If they're closer to the top of the corona, they will be ejected outwards into space, and they will become the Sun's solar wind. And for more details, you may look at Article 175 entitled How is the Solar Wind Produced? And my book entitled Planet X Reveal Gravity and Light. Now, in the beginning, when I deduced that there must be an interaction that causes positive and negative charges to be separated, I actually called it the charge separation interaction. And this was before I realized that it was actually just another part of the gravitational interaction. The gravitational interaction can be both repulsive as well as attractive, just like the electrostatic interaction can be either repulsive or attractive. Now, planets are not very different from stars. Planets also have electrical discharges in their atmosphere and thus also emit light from their atmosphere, just like stars do. On Earth, lightning discharges lead to the emission of gamma rays, which are energetic enough for positrons to appear. Positrons are electrons with a positive charge and are usually also referred to as anti-electrons. I, however, do not believe there are any such thing as antimatter. They are only particles which emerge from within photons with a certain mass and which can have either a positive or negative charge. However, planets do not generate enough gravity through the energy generation process in their core to have a flux of ions from their atmosphere and thus produce their own nebula ion clouds. If a planet was able to generate its own nebula cloud or ring structure, then it shouldn't be classified as a planet at all. It should be classified as a star. However, planets also have nebula clouds or radiation belts with particles in them. The particles in the outer belts of the planet seem to come from the sun's solar wind rather than from the planet's atmosphere. If there are any particles that come from the planet, such as high-energy electrons, these will join the solar wind electrons at the appropriate energy level, or in other words, orbital distance from the planet. Nebula ion clouds have lower gravitational energy the further we move from the star at the center, as an ion's energy comes mainly from the number of protons in the nucleus and is thus mostly in the form of mass. But as we move further out from the star, lighter elements will populate the nebula clouds, so the ions will have less mass and therefore less energy. So this is illustrated here. The gravitational energy in the form of mass increases towards the center of this system of clouds. Well, for the sun, it's what we call the solar capacitor. So we have light nuclei here, or light ions such as hydrogen all the way down to sulfur, and we get heavier and heavier until in the first cloud, nebula cloud, we'd have metallic ions like nickel and iron. So these are heavier and therefore have higher mass and therefore higher gravitational energy in terms of mass, or in the form of mass, than the ions in this outer cloud. So mass increases towards the sun, whilst the gravitational energy in the form of photons inside the electrons increases as we move outwards from the sun towards the edge of the solar system. So that means that the electrons in these different energy levels, or electron clouds, will increase in energy as we move outwards from the sun towards the edge of the solar system. Now, mass and gravitational energy are two different forms of energy which originate with photons or light. Thus, both are made out of light. When a photon splits into two particles of opposite charge, part of its energy turns into the mass of the particles, and the rest continues to exist as photon energy, but inside the particles with mass. Thus, particles become containers for photons. So this is illustrated here. We start out with a photon, which has constituent particles inside it to start off with. But at this point, the mass has not manifested. What we have is a photon with a certain energy, no mass, and moving at the speed of light. But when the photon moves through a region of high enough electric field, the two particles that have different charge get pulled apart and come out of the photon, and at that time the photon's energy turns into the mass of the particles, and the rest turns into photon energy which exists within the particles. And I call it gravitational photon energy because it is associated with the particles' ability to interact gravitationally. So in conclusion, the gravitational interaction leads to the sun, and by extension all stars, having a structure of nebula ion clouds and negative electron clouds. The gravitational energy of electrons in the electron clouds increase as we move outwards from the star, just like the energy of the electrons in an atom. And the ions in the nebula ion clouds increase in energy in the form of mass as we move inwards toward the star. And these are the references. This is Dr. Claudia Albers, Planet X Physicist. Thank you for watching.